Welcome to Stay Sharp in Digital Engineering, the podcast that sharpens your understanding of digital innovation for products and manufacturing. We're really glad you're here. In today's episode of Stay Sharp, Jonathan Scott and I welcome our guest, David Ewing from SAIC, to help us debunk the myths around digital twins. We discuss terminology, models versus twins, configuration management, and AI's role in enhancing digital twins, as well as highlighting the importance of a digital thread to support the digital twin. Let's jump in. Welcome back, everybody, to Stay Sharp in Digital Engineering, the podcast about all things digital related to products from engineering, manufacturing, service, and more. I'm one of your hosts, Julianne Grant, and today I'm joined by my co-host, Jonathan Scott.
Hello, everybody.
Hey, Jonathan. It's always good to be here, back in the seat.
It is. Every week or so, it's good to have these kind of conversations, and I'm excited about today's and our guests both.
Yes, me too. So today we are continuing our series on digital twins. And today we're talking about the myths and misconceptions around digital twins. And, as is the case, anytime a new term comes and makes its way into the marketing vernacular, which I have to say I'm guilty of creating some words, digital twin has become somewhat an ambiguous term, and it can mean a lot of different things to a lot of different people. So we wanted to take a look at what a digital twin is and isn't, and help clarify and overcome some of the misconceptions that might be out there on the concept. And to do that, we have a special guest with us here today who actually knows where the rubber meets the road when it comes to digital twins. Dave Ewing from SAIC. So many of you may know Dave. He has worked in the PLM industry, and his current role puts him in a unique position to talk about this topic. So we welcome Dave to the podcast.
Hey, great. Thanks. Appreciate you having me.
Yeah, we're really excited to have you here. So just a little quick background about Dave. He is the strategist director of mission integration at SAIC, and is the architect behind ReadyOne, SAIC's award-winning digital engineering platform for the Department of Defense, which is pretty impressive. In his role, Dave assesses current technologies and identifies areas for improvement. He develops strategic enhancements to align technological capabilities with client missions and oversees the implementation of key technology initiatives. He collaborates with research teams to integrate technologies. He leads cross-functional teams to help its mission integration practice, and drives digital transformation across defense, space, civilian, and intelligence markets. That's quite the background, Dave.
Yeah, I try to keep the acronyms out of it, right?
Right.
More words.
Exactly. But he also holds certifications in configuration management, project management, and Six Sigma. So you're well-versed in this digital engineering, digital manufacturing world.
That's what I'm so excited about, right, Dave? Is that we've known each other a while, and I know you know this stuff, so it's going to be fun. I want to just jump right in and kind of set the stage for some questions to talk about today.
Fire away.
Yeah, and like Julianne said, you've got a unique perspective on digital twins, having worked in industry and at a software OEM, right? So you've seen a bunch of sides of this.
Yeah.
So anyway, and doing that at the time that a bunch of these concepts were coming of age. So let me just lay a little bit of groundwork. I'm going to throw a few terms out there that we use, and we're not pedantic about it at all. So I recognize some of these terms are not other terms that people use, that kind of thing, but I want to get the concept so we can kind of talk around them. So a lot of people put digital twins in categories based on kind of the interactions between the digital and the physical, right? Yep. So a couple of terms that we've used, like I'll say digital surrogate is the one I've used on, meaning a digital model that's used to control the physical instance. But digital shadow is when a digital model is updated from the physical instance, right? Think sensors and feedback from the real world, that kind of thing. And then another one, virtual twin, and I know this one's kind of a pet peeve of yours, so I'm interested to talk about it, is when there's a digital model, but you don't have a physical instance, right? So I won't steal the punchline about that one, but anyway, so those are the couple of things that we've used as terms to try and give some language to the fact that these things aren't all the same. And obviously, I guess I should have started with digital twin is that full back and forth, right? So if surrogate's one way, shadow's the other. Digital twin meaning, okay, kind of closed loop, you're getting data or information moving in both directions. Having sort of said that, laid some groundwork, I want to just get into those details and keep teasing out things related to terminology. So a big one that I think in the market is confusing today is twin versus model, right? We've had models for years, but suddenly now we got digital twin we're talking about.
Yeah.
Okay, so from your view, what makes something a twin versus just a model?
Well, first of all, like the term itself, twin, right? So I'm just an engineer. I don't have a very big vocabulary, right? So twin's a complex word. So I looked it up in the dictionary. You know, it means two, right? There's two of them. So, which leads you to believe that to be a twin, I have two. The key thing is to have the physical, the thing, the asset. I always grab one of these when I'm talking to people, but because it's something physical, right?
Right.
But I can have a digital twin of my phone because I have the phone, and that twin then represents its condition as it stands right now at this moment in my hand. And if you expand that to whatever industry you're in, it's easy to think about, aircraft, right? I was flying home yesterday through Atlanta. There's rows and rows of aircraft, right? So each aircraft is slightly unique in terms of how it's been maintained. The twin is of that specific aircraft, that tail number with its configuration. So to have a digital twin, you've got to have the physical asset. That's kind of a binary, and it's it kind of sometimes gets people's dander up a little bit, but hopefully we'll explain our way through that.
No, I think that's right. It makes sense, and it makes that term virtual twin a little weird.
Yes.
And I don't want to explain that for someone else. I know there are people who advocate for it. I don't necessarily advocate for it, but I get the idea that maybe where that can still fit is, okay, if you've got a big collection of models that somehow really represent the whole behavior or the whole something of the physical asset, it's just the physical one hasn't been built yet.
Yeah.
But you're building it so that you will have a digital twin once the physical exists. Like that's how I sort of interpret it and say, okay, it's not just a fancy word for a model.
Right. And that's, like Julianne mentioned in the intro, a lot of the marketing is saying, oh, I've got a model. I've got, 256 colors, whatever it is. So this is a digital twin, right? No, that's a model, a virtual model, a virtual twin, what do you want to call it? To be honest, we've had them for 30 plus years now, right? CAD is not new. MBSE isn't new anymore. We're developing more and more capability in those fronts and other types of descriptive models and simulations. They're all extremely valuable. The point here is not that they're not valuable. They're a piece of getting you to twin. They're the perfect engineering. It's really not even perfect. It's the assumed perfect, right? Engineering 101, state your assumptions, right? When we all had our paper and pencil, doing statics and dynamics, you state your assumptions, as you start to crank through the equations. And that's, hey, I'm assuming these things. I'm assuming these conditions. I'm assuming that these models are perfect. There's no tolerancing on them yet. There's no reality in what this thing is. And those are good. That gives me that as designed, often called EBOM condition. This is in the perfect world how I want this thing to be. And that's more than a BOM. It's more than a CAD. It includes those sims that give me characteristic data, that give me this is the performance I expect to see out of this thing, this aircraft, with these mission conditions, those kind of things. Super important. And we should do more of that. It's like by saying digital twin, this or that, no, we should actually do more sims. We want to make the virtual twin even bigger. Right.
Yeah, and keep building out the virtual twin.
I'm sure.
Yeah. I think it leads me to another question I knew I wanted to ask coming into this today, but I think I know the answer of it already. And it relates to this topic of, the myths part of this. Are CAD models digital twins? Can they be digital twins? Based on what we just said, I know the answer, but I mean, why not? Like, what's the thing?
It's a model. It's not a twin. It doesn't represent the thing. It represents the thing as you're trying to design it. So you just keep with the aircraft. This is how I intend this thing to look. Yeah. The same way that I build a MBSE model, it still represents the thing that I intend to make. One just has graphics. The other has boxes, right? So are they a twin? No, not from that perspective of digital twin. Do they feed the twin and become part of it when the physical asset is generated? Ah, yes.
Yeah.
Now is where the game starts to change. As I transition out into, through the digital thread, right? And that's a key thing. You've got to have proper config management, proper digital thread to get there. Now that I have that thing, at the moment in time, let's assume no deviations in manufacturing, right? Because that's a whole nother rabbit hole we can dig into.
Yeah, actually, that's what I want to dig into next. But go ahead, keep going.
So for a moment, assume, hey, everything's rolling off perfect. I've got Toyota production system. We're great, right? We rock these things out. So I'm rolling aircraft off the line, and at that moment in time, that physical asset matches the as-built condition matches as designed. It's perfect. Right, setting aside tolerances again. Right, we know these things don't all. The panels don't all come together perfect like they did in CAD, and that's the big difference. Is you're getting those imperfections, right? Which the deviation part you want to get to, is part of that, right?
Yeah.
Now at that moment in time, I do have the twin because those two things should be perfect. That's kind of the picture you always see: the aircraft, the physical picture, and the graphic, the 3D meshy graphic of it, and that's what you have that moment in time. But as that aircraft changes, we change the oil, right? That kind of thing. Oh, after X number of landings, I have to replace the landing gear.
Right.
I have to maintain the engines, obviously, things like that. Well, maybe I can't get the same exact landing gear or the same bearing. So now that aircraft, that asset is subtly different. It doesn't match the CAD anymore.
Right.
It doesn't match the system model anymore. This is where now that twin is taking a life on its own. Now I need to rev the CAD into a unique instance. Not the perfect fleet, singular CAD that shows what the fleet should look like. Now I've got a one-off of the system model, of the CAD model, of the simulation. Because, man, hey, new landing gear, can it handle the stress? If I just go buy it from these guys and put it on, I'm being a little facetious. Right. but that idea, is it going to fit? Is it going to be able to handle loads? Is it going to handle this many landings that we expect to before we have to replace it? Those kinds of things. So now I've got a unique twin.
And you're getting into really the point of the value of a twin over the value of the model, right? Because the value of the model is that idealized answer the question, but the twin is that specific answer the question.
And going back to the engineering assumption thing, now's my chance to throw the assumptions away. Right? I've got the perfect model, but I don't live in perfection, right? So now I can take that perfect model, revise it, and use, like I said, update the model to include the new landing gear. I got some new CAD, I've got some new system characteristics, whatever it might be. But also, how is that aircraft being flown? Because now I have access to more data. Give me all that sensor data.
Start to replace those assumptions with real information.
Right. So whatever those assumptions are, hey, this is the actual profile that this aircraft tends to fly, and it's a little easy. It's not commercial aircraft. It is easier to think about it in military aircraft. So forgive me, viewers, right? But the idea, right, as I fly at 36 hours from here to the other side of the world, based on the recent news, right, or what have you, or I'm always flying this mission profile. I'm always in Antarctica or Alaska, that's more real, or I'm always in the desert. That drives, hey, the bearings wear out. This is my silly example I always give, right? The bearings are wearing out sooner whenever I fly in the desert, somewhat obviously, right? Lots of sand, it's a harsh environment. Well, maybe I have to change my maintenance procedures because of that. Because I'm seeing information. Now I can model that in that twin. I say, hey, what should the maintenance be? Go update your mean time between failure and logistics models that you use based on, we used to think we'd replace the bearings every 3 months. And I'm just throwing numbers out. But based on what we're seeing, because I have these models and I have the actual usage of the asset, I can now replace those assumptions like, gee, gosh, we got to replace the bearings every month.
Yeah, it's that whole now that I know better, I can do better thing of once you get the information.
So that's a simple change. That's a maintenance change. So I really haven't changed the aircraft. The other one is, hey, there's better bearings.
Right.
Now I've changed the twin. That's where I need to go now, change the model, change the CAD. If bearing kind of looks like a bearing, granted, right?
Right.
But the idea that I've changed the system, I've changed the thing.
That's right.
So, now I have a unique CAD with a subtly, one of those subsystems is different.
And back to your
sourcing
configuration
change or
management
something.
point.
And that's why you've got to have the config management to know that, hey, at this moment in time, if you kind of follow the timeline or digital thread or vModel, wherever you want to go, at this moment in time, it was perfect. This is when we sent everything off to the assembly line to be built. And as those things came off, they were theoretically perfect. But they all start to veer into their own digital thread, and that builds their own digital twin, allowing them to know that, hey, that maintenance order drives a change, ECO, ECR, ECN, whatever your favorite is, right? That says, okay, this as built condition, because now it's a new bomb, is now going to be changed. And now it's as maintained, right? Because I'm changing it. And it's got that new bearing, that new subsystem, that new landing gear, whatever it is that's in it, that now I've revved the system and I've added a new thing. And there's a whole interchangeability discussion you have to put in with that. But that's another podcast discussion, right?
It sure is.
Or we'd be here until lunchtime.
Yeah, we could.
Yeah.
So I want to come back to that point, though, about the question I was asking about the models and the twins, because I feel like there's an interesting place where we get into a gray area about some of the technology today, about model-based quality, model-based things where we're bringing real-world data back in, right? Yeah. And this, to me, is where it gets a little weird, because I'm on the same page with you. I agree. It's still a model when it's a virtual idealized representation. Yeah. And like you said about tolerances, I'll give an example of what I mean there. You model in CAD, hey, I got this tolerance zone on the part. It could be this big or this small. Right. But now if we run it through our quality process as we're making the instances of it, and we get data back that says, actually, serial number 1 was exactly this big. Serial number 2 is exactly that big. Serial number 3 fell outside of the tolerance zone, so we threw it away, et cetera, et cetera. Those models now, are they models or twins? I don't know, right? So I wanted to throw that one back at you. What's your take on that?
It's a great concept, because that at that point, that model is a twin, because you have the physical thing and you're capturing it's because you're right. We haven't really seen anyone taking the as built at that moment in time and taking the ruler to it, to your point of saying, all right, here's what it really is. You have to be measuring every part. So you should be capturing an MES.
Right.
So I'm checking the tolerance on every part as I put this thing together, right? Each subsystem I'd know. And that, to your point, then I've got this big stack up. So I may be doing, statistics on that, Monte Carlo simulations, whatever, which would be ideal on the virtual side. Hey, I know as long as I'm in these ranges, all my, Lego blocks are going to fit, right?
Right.
And because Legos have tolerances, right? So that happens all the time. But to your point, that is a really cool thing of at that moment in time, not only have I kind of derived, but I should have the perfect condition. I haven't seen a lot of companies that tolerances like that and capture them in a structured or semi-structured manner and relate it to the configuration.
Yeah.
Right? Because more than likely, and this is a whole digital thread conversation, and really it's a PDM conversation. You can't just throw your data in Teams or whatever and expect it to be digital thread, right? That's not the answer. It should be related to that product in some way, shape, or form. And that's not to say the data has to be in PLM or PDM. Single source of truth can be many databases of truth as long as you have one overriding connection. But anyway, that's another podcast, right?
I love your point, though, about you can't just dump the data in Teams. It reminds me of a quote from actually a customer I worked with on the DoD side. He was like, here's the problem. The thing that we're getting is a complex assembly of 30,000 parts. But as we get the data delivered to us, it's actually a dump truck full of Legos. And I'm like, that's a great way of looking at it.
Yes, it is. Now I got a giant zip file. Why do all this stuff? Right. So yeah, absolutely. So, and I've had that kind of conversation like, oh, hey, I want to connect all this stuff. Well, I've got my CAD in a PDM system, and oh, we've got it. Like, well, where's your simulation models? Where's your MBSE models? Oh, they're in this shared folder drive, the Teams, SharePoint, whatever, Well, they're not connected. Therefore, you don't have a thread. It's very hard to make a twin.
Well, I think, too, the thread issue is one of those myths and misconceptions. I think that, we talk to people and they know what a digital twin is if you ask them, but they don't really know what a digital thread is. And so, there seems to be a little bit of a gap in how people might think about how to actually deliver a twin. So I don't know if you see any of that, or people aren't really thinking through the thread aspect.
I'll preface that with, it's easy for us to sit here and kind of postulate, like we're bringing the commandments down or whatever, right? And say this is thou shalt. But the world we live in is gray, and not everybody has the time, ability, funding to just say, time out. We're going to stop producing. We're going to go build all these digital systems, right?
Right.
So with that said, it's like you got to start somewhere, but it's the agile kind of approach, crawl, walk, run, whatever you prefer. But not everybody knows what a thread or twin is. Yeah, because I think a lot of times they're thinking, well, I have a model. We had discussed that. That's thread or that's twin. No, it's not. But I think we kind of beat it up a little more. But then the thread idea is I need to capture all the data and relate it together. Now I've got a prescription for how, we like the way that we did it in Ready One. Heavily configuration managed, including the line that connects two boxes on a digital thread, like on a slide when you're showing it to someone. There's a lot of context in there. There's a lot of configuration that people think, oh, it's a little line, no big deal. No, there's a ton of stuff on that little line behind the scenes from a configuration perspective. Business rules, all kinds of things that happen under that when you make that connection. So would I prefer a more robust model? Sure. But going back to not everybody can, jump into it and dump $1 million and go and do it, in a perfect environment. There's other way, it's if you're at least making some type of, I call them just generically hyperlink style links, at least that's a start. Mm-hmm. But I want to know that, hey, this requirement is what drove the system model. This CAD realizes this system model. This simulation and this test validate, so now you're into IV&V, right? I'm verifying and validating that I did it. I met characteristics and I met requirements, those kinds of things. So I need to relate those together. Do I need them all in one big PLM system? No. But do you need them in multiple PDMs? Likely, yes. And Teams is not one of them. SharePoint is definitely not one of them. Sorry,
or
folks.
Excel.
It's not.
Right.
But if it's all you got, it's a start, right? I always talk to folks and I'd rather have you using Excel for requirements management than one of these.
Right.
It's like there's like
gradual
it's a model, right? And so I'd rather have you getting links together. So at least, hey, I might have to sledgehammer my way to get some answers to find things in the thread, but it's better than nothing. You're gaining the intelligence, the business intelligence about what really is, and you're starting to learn the impact assessment of, gosh, I got to change this thing, or I've got that bearing problem. Hey, if I got to change the bearings, what do I got to change?
Yeah, no, it's a good point. It's a good point you just made, Dave, about a document-based digital thread is better than no digital thread, but a data-centric digital thread is really what you want. But you might have to take steps to get there. I think that's a really good point.
Yes. I did a presentation at the ARIS conference 2 years ago, and one of the things that I talked about was the idea of, rewind the clock to 1990. It was digitize, right? It was the idea of going from paper drawing to the CAD-based drawing kind of idea. And that applies to other areas. The CAD drawing is an easy thing to think of. And then there was, as you move through the 2000s, and it became this digitalized thing where you're starting to tie together these digital tools. You're starting to gain more capability. And then this, whether it's digital engineering or digital transformation or whatever the third step is, different folks like to call it different things. This is where the holy grail sort of appears, and you start to, efficiency flows and cost of business goes down and all those things. Everyone says, well, it's not working. Yeah, because you didn't do the second step right. You didn't finish the second step. And the reason I bring that up is I was at a digital engineering summit this past week in DC, and one of the longtime heads of the digital engineering folks in the Department of Defense, she basically gave the same presentation. Philomena Zimmerman, she's fantastic and witty and funny, and it was really funny. It's like, yep, that's a huge gap in terms of, kind of going back to the idea of I'd rather have a paper-based. I'd rather model-based is better. But you got to go finish that second step to really get to the model-based. Otherwise, you're sort of still stuck in document-based. So it's not easy. It's just it's work, that's for sure, right?
Right. Well, what are some of the other myths or misconceptions or exaggerations that you might have hear about the digital twin? Or, kind of, it's got this sort of big promise to it. But, are there, where's the reality there?
Well, a lot of times just because I've got, it's going back to kind of what we've said, that because I have some data and some models in some type of semi-structured storage, right? I've got a thread. Or, here's the better one. Here you go. Because I can take my requirements or my system model, what have you, and I can export a text file, and import it into the next step. I have a thread. No, you don't.
Right.
Right.
The thread, the whole point was the linkage. Now, again, I'd rather have you doing that because at least you're using the data, ideally, because these are fallible, right? I can screw up, pipe the information in, right? Easy to do, right? So at least you're trying to say, hey, I'm starting to eliminate some of the opportunity for that. So that's a good. It's a start, to be fair, right? But yeah, that's always a good one. I can move some text files around and say it's a thread. Now, so if you do, then something bad happened in the field. Someone died, right? So here's the legal, because the lawyers are going to say, prove to me. And here's where the thread comes in. Oh, I can go from that asset and walk backwards through the thread, through every engineering decision. Because one of the things that people forget about in the thread, and a lot of this is, you see the boxes in the diagram that represent CAD model, system model, whatever, requirement, simulation, right? Colors, it's pretty. Behind those boxes and those lines are engineering practices and processes.
Right.
Work was getting done. Change orders were being affected. Decisions were being made. Material choices were made based on requirements that, didn't work and something bad happened, right? This is not a real case. I'm totally making it up, but why did you use that material? Oh, that was a requirement. Or, no, you didn't meet the requirement and no one verified it.
Right.
Or what have you, right? Whatever it might have been, something bad happened. That's what the lawyer's going to want, right? But having that connected thread, I'll say, all threads should be connected, but I'm just trying to differentiate it with a word versus the text file copy.
Right.
So the text file copy, you're going to say, oh, great, I got this great model. Here's my CAD and here's my simulation. Well, show me how you got there. That's in this folder. That's in this folder. Let me try to put it all together for you and draw the picture.
Yeah, or let me remember, or it's an email or whatever.
Right,
but
exactly.
Your point is the outcome that we see on the slides.
Happens over multiple years, right?
Right.
And multiple changes in staff. You may or may not even have the legacy of the data, right?
Yep.
Whereas with this what I call true thread, and the connection is a key thing. I can trace back. Back in the day, digital thread was just called traceability. Right. Back in the day.
That's true.
That's really what it is. It's a marketing construct. It's a good one, right? But I can go back and see, hey, why the heck did we do this change order? Why did we choose this thing? Did someone run a simulation on this? No, why not?
Yeah.
Those kinds of things that it gives you the provenance of how the data was generated and decisions were made.
And to your point, when you know that, you have more context, right? When you have richer threads, you have more information about the decision, the discussion, the process, that kind of thing. Yeah.
The context is simple word, but I think that's part of what changes the game is the context. And going back to the aircraft example, if I'm starting with mission engineering, it gives me a context of what I think I'm going to be doing. As I start to work my way through the systems engineering, more and more context as I get into the mechanical, electrical, software development, I have the context telling me, hey, this is how we expect this thing to work and what to go on. So context is huge.
So I want to get into that because I got one really big question I want to make sure I ask related to misconceptions about digital twins, because I don't want to run out of time on this one, right? when I think about the context that we're building out with these things, and by doing it, I'll say explicitly, right? It makes me think immediately about AI, right? And of course, AI comes in every one of these conversations. When I think about what AI can and can't do today, what I understand about it, it makes me wonder, somebody's going to try and build a digital twin using AI. What do you think about that? Is that going to work? Is that a good idea? Is it a bad idea? Why is it not going to work if it doesn't?
I think you can use the technology on the table right now. I mean, we're using some of the AI to do some of that now, every day. Could you use AI to make the connections of the data? Yes. I actually think AI is going to become our connectors of tomorrow. As I'm generating information and assets, I'm going to have my little army of agents. If you're not familiar with that, it's like basically little miniature AIs that are doing your bidding, right? They're your minions,
right.
from Despicable Me, right? Little yellow dudes
off doing things,
right? Yep. Doing whatever it is they need to do. So yeah, could it be making the linkages and doing the things? Yes. The other side of that, we are already using AI to take all that data that we talked about, that the IoT sensor data, whatever it might be, those big data sets that we're seeing to, the real usage, to then take a look at that, smash through the numbers and find the trends. So the pieces are already starting to come together, and, technology's moving fast. So things are coming together really fast. I think as people figure out how to take their artifacts in the digital thread, all of them, and as they're generated, submit them through into the AI refinement models, whether it's RAG or, there's different ways, and that's again another topic. Then you've got a recursive loop of refining your models too.
Right.
I mean, a simple thing we do all the time. Well, I got a spec that's 75 pages long that has a gazillion requirements. But, we got a simple model that slices and dices through that and says, all right, here they all are.
Right.
Pop in the doors. Really simple, really fast.
Yeah. So what I hear you saying is lots of places where AI is going to help us, but I'm wondering the big picture question of, are people going to be able to skip a bunch of steps? Are they going to be able to say, look, I know my data is in documents, it is in SharePoint and Teams, it's not configuration managed, just throw AI at it, it'll solve it. Are we going to get there?
In theory, you could say, let's say the memory was persistent. In theory, yeah, you could have a digital thread that all be in memory. I don't think that's the way we'd want to go, but the ability to skip steps. I don't have to, mentally ingest that document. So one of the things we like to call it at SAIC is this idea of a 10x engineer. And we've been talking about this automation stuff for years of how do you make people more efficient? That's really what it is. I don't have to smash my way through a document. I can have the AI do it. And now you've got to train your models and verify them, right? There's an assumption that goes with this that you've done that. So setting that aside, that I can say, hey, it smashes through this. I know it's accurate. Great. I don't have to go and find all this information. Here it is. It's put it in a nice table, with a bow on it for me. Yeah, so a step gone. So all kinds of steps absolutely can be eliminated now, right? So that's really useful. We're automatically writing test cases now. And I think that's an entirely achievable thing for folks right now using, I would not use, the chat GPTs or Anthropics of the world using their servers. You should put them on your own. And, I highly recommend you, whatever.
Privatize your AI, yes.
Whatever cloud favorite you have, right? They can serve you the models, but then the work happens in your own, your own instance.
Right.
Highly, highly recommend that, right? Don't trust the other guy with your data. But I could definitely save time by saying, all right, hey, we wrote this code. So we're using SysML model to drive code. It's building out the code structure for us. We've got a SysML for software schema or style guide that we've built. And so it boom, ADO already has the structure ready. And then they go in and push a button and the agents start to look at it and say, oh, here's the tests that you should run based on this code that you just wrote.
Right.
So is that human out of the loop? No. The human still verifies all those things for now, right?
That's the key.
I think it stands to reason that as things get better and better, we'll be able to know that they're good. And we can say with 95% accuracy that this is good, this is good. Hey, this one, I still want the human in the loop. So right now, we're still keeping the human in the loop, but even if it's 50% of the work is done, one of my really expensive, really smart engineers isn't writing the test case. They know they need to have the test case. It's there. They're verifying that it's done right. We say the same thing with systems engineering. I don't need our systems engineers to use, one of these, right, to draw boxes in their SysML tool of choice. I want them to know how to model it. So if I can have a tool help them do it, they're more efficient.
So you're in the same boat that I am, which is AI is going to help us get there, but it's not going to do it for us, and we shouldn't let it do it for us. We've got to trust but verify.
AI tools are not silver bullet.
Yeah, okay.
Right. They're not magic.
They're accelerators. Will they be
some point down the road? Likely, yeah. And that's also when Skynet forms, and now we have another problem.
I'll never forget that movie.
Age, right?
Ever. I think I was 14 when I watched it. But I'll never forget it. Yeah, I don't think anybody wants a Skynet. So,
well, it's.
But it is concerning. But I think it's really interesting.
AI, you should have an ethics panel that looks at it.
Yes, you're right. Absolutely, That's a really good point. I think AI is so exciting because it just, like you said, it can 10x an engineer, or can 10x anybody, really. It just helps you accelerate, mundane work that you don't really have to do anymore, which is certainly highly valuable. I think
its ability, I say it, but you got to pick the right model. Like out of the box, Anthropic Claude 3.7 writes code really well. Mm-hmm. Is it perfect? No. But, you want it to do a Python thing to do, all right, here's a recursive thing. I want a Python, a little piece of code that'll take a PDF file that's 85 pages long and slice it into 81 pagers because it's easier to feed that into a RAG model. Hey, Claude or ChatGPT or whatever. Yeah, the out of the box. That's an area. Hey, go ahead and use the web one. Learn how to use some of these things. That's fine. You're not putting your IP potentially out there, and it'll write you the code. And then you can even say, hey, how do I compile this? Or hey, how do I put this in Visual Studio Code or whatever? And it's great. And then it'll say, do you want me to send this to you in a zip file? Yes, right. So you can do all kinds of things that suddenly make you better. Now, all you developers out there, I know you're there. You're already like waiting to comment. I know, right? But I broke the fourth wall. But now, the problem is that your software developers now don't know how to code as well, potentially.
Mm-hmm. Well,
right?
There's that.
Right. So, but I take that back to the systems engineer point I made a moment ago. I don't need you necessarily using the mouse and drawing boxes. I need you to know how to model it and make sure it's modeled right, descriptively. If I can speed up the mechanics, is a good thing. So I still need really good software architects to architect and say, this is how I want it all, really to draw the system model of the software. Right. Well, and I can have all the chunks of method and the classes written by a little AI agent potentially and speed those folks up. Right. So,
Well, this has been a fun conversation, but I'm going to have to put a leash on us because we are approaching our 40 minutes. I know. I hate being the bad guy. I'm always the bad guy here. It's a great conversation. But
it's okay, Dave, because normally it's me. But at least this time, I've got a brother in arms. The two of us together can do it.
This is a challenge. Yes. We got the two horses. So, Jonathan, can you take us... typically, we'll go through a bit of a summary. Jonathan will help us summarize what we learned today.
Yeah, so here's what I took out of what we were talking about, Dave. I think it's all been really good talking about the myths and misconceptions around digital twin. And of course, we got it down a couple of side alleys, but I think the big things are twin, right? Twin needs two. That's a good point that you're making. And when people use terms like virtual twin, you got to think, well, what do they really mean there? But when we get into that twin term and we think about what we're really talking about, pairing physical with virtual, that's what helps us understand and differentiate and make sense out of all these terms. Model's not a twin for that reason. Now, if you are modeling the real world, maybe it gets into a gray area, but I think that was an important thing we talked through.
Sure.
Another thing you said that's key is configuration management. You got to have CM to make all this work.
Amen.
And that means structured systems. So don't think that you're going to do it without that kind of structure. Another piece that I think was a good takeaway, key point that you made is crawl, walk, run. Understand that you can get value out of these things each step along the way. So don't, wait until you've got it all the way you want it. Just get started.
Yeah.
And I think another thing that you mentioned is these terms, they sound fancy. Some of them are new, like thread, but we've been doing it for years. It's traceability, right? It's traceability, but with digital added in so we can do it more easily.
That's right.
And then the last takeaway I had was what we were just talking about related to AI. Yeah. AI isn't going to build these things for us so that we just like snap our fingers and go, but it sure is going to help us get there. So think about how you use it to get to where you want to be. That's what I heard out of what we talked about. What did I miss? It was really like, we got to make sure people heard that too.
I think those are the points. You've nailed them all. I think, for me, bottom line, digital twin isn't just a pretty picture, right? It's the idea of just having a visual of a model. Yeah, that's great. I want that twin to be the living model that evolves with the asset. And it should be fed, it should be based on config management, just like you said. It's now fed by actual real data. And I keep deriving that thing. And I keep adding, we talked about bearings or landing gear or whatever. It's always growing with that asset. So I can see it. I can see the fleet. I can now get big trends. And now it all comes back again to how I design the new thing, right? the new aircraft. Right. So there's a feedback loop that goes in there. If not, it's just a pretty picture.
It's a model.
I wrote a blog and I actually called it a digital trophy.
I love it.
Yes,
I love it.
Yes. In fact, I saw an interesting post yesterday that you did on digital twins. So thank you so much, Dave, for being here today. This has been a great conversation.
It has been.
And we always like to leave the door open for you to come back for another conversation later in the year. Be great.
I got questions.
That'd be blast. Let's find something else to chat about.
Absolutely. So you can find Dave on LinkedIn. Follow his profile. He's got a lot of interesting things going on there. And as usual, we could cover a lot more things on this particular topic today, but we have run out of time. And if you have any comments or feedback or questions for Dave, please make a comment on our post. Give a like to our post if you enjoyed this conversation. And we hope you tune into some future episodes. And with that, everybody, have a great week and stay sharp.
Thanks, Dave.
Thanks, Dave. Thanks for being here and listening to this episode of Stay Sharp with Razor Leaf. If you liked our podcast, please be sure to hit the like button and subscribe to our podcast on your favorite podcast platform or check us out on YouTube. If you have any questions, please leave us a comment on our post or send us an email to podcast@razorleaf.com. We'd love to hear from you. Until next time, everybody, stay sharp.